Hello, how's it going? It's Anthony here, and in this short video I will be showing to you how to add simple vehicle dynamics to an arbitrary car model. So for this purpose I downloaded two files. So first we see EasySuspension, which is a demo I created a while ago to demonstrate how to work with wheel colliders in an easier way. And this is an archive which contains a vehicle model I want to add dynamics to. So first, let's unpack the archive and see what's inside. Let's go to a better view here. Right, so we have a bunch of textures over here, and an object file, a material, and a die file, which is useful to get a preview right in Finder window. So now we see the vehicle is a 3-axle truck, which I would suppose to be a military truck, but I have no idea honestly what kind of truck it is. So if you know what it is, just leave a note in the comments. I got this model simply by googling for free car model, I think, and I found a database of different models available freely. And I like this one because it came with a nice texture, and also it had 3 axles, and it came in a format suitable for Blender. Now let's see how we get this car in Unity 5. So here I have EasySuspension. Now let's unpack it and open in Unity 5. Here we have Unity 5. This is a developer version of Unity 5.2, but you can easily get the same results in 5.1 and 5.0. Let's open EasySuspension demo. Here we go. Now let's wait until it imports everything. And something more. And now small assets, and here we go. Right. So here we have Playground of Unity, which comes with the EasySuspension demo, and it already has one simple car which has 4 axles over here. So to control, we have to select car route and press F 2 times to focus your camera on the car route, and then switch to game view to pass input. So we are looking over here and controlling it from over here. Here we go. We also have some simplistic terrain over here. We got a plane and something like simplistic bumps, and we have terrain over there. Nice thing about this project is that it comes with a script that allows to create a wide variety of vehicles. It's available right here in Vehicles menu. It's Boxycar Wizard. You just get this window and set how many axles you want, set the mass and the distance between axles, and set car's width and how low you want to have your axles below the center of gravity. And then you just press generate. And here we go. This vehicle is already configured to work nicely. You simply press play and it works. Here we go. If we press forward, it just starts moving. It can steer and brake and go backward. So currently I have the same controller attached to both vehicles, so they move simultaneously. The reason why I find this demo project so useful is because of the EasySuspension script, which basically takes natural frequency and Limping Ratio is input, and works out all of the WheelCollider properties automatically. That is, spring settings such as stiffness and damper, as well as others like force application distance and suspension distance. And that way you just simply get as less physical artifacts as possible. You simply tweak those two values and get all of the settings for every wheel automatically, so you don't have to mess around those properties again. So it effectively lets to go down from tweaking how many, like 5 or 6 parameters per each wheel to just 2 parameters per vehicle. That's of course a simplification, because if you want to behave different axles differently, then you'll have to separate the script and compute different parameters for axles. But in this simple scenario, I just take 2 parameters and assign them to all wheels. And I think it's pretty suitable for simplistic cases. What I'm going to do now is to create a simple box-shaped car corresponding to my 3D model, and then bring the 3D model in and replace the box with 3D model. Right, so first let's clean up the scene. Let's just simply remove the two cars we have already. Now let's see our 3D model again. Here we go. So it has 3 axles. So let's go to Vehicles, Boxy Car Wizard, ask for 3 vehicles. I don't know about the mass, I just don't care. I don't care about other parameters as well. So here we go. This is a simplistic car that corresponds to this one. Now I'll try to bring this graphics model over here and have it working perfectly. First, let's see if our starting point works. Here we go. So it's able to steer and it's able to drive. Right. So now I'm going to copy track and put the whole folder inside the EasySuspension project. So I go to Assets and just paste it over here. Now we wait for the import to finish. Some textures, what else? Small assets, of course. An object file. Come on. Right, here we go. We got track. So we have the model saved in 2 different formats, the object and the die one. Let's see this one because it doesn't look rotated. Wow. It's big. Yeah, it's big. Well, whatever. Alright, so first let's see if everything is correct with the model. So we see that it's aligned along Z. That's good, because with Unity 5 all vehicles should be aligned along Z. That is, Z is the direction of the movement forward. Good. So let's see what's inside. Boom. So here we see that we only have one mesh. That's not super cool, because we need all of the wheels to be separated from the main mesh, because we want to be controlling them. So that's not a problem, we'll just simply use Blender to separate the wheels. So now let's just simply switch to Blender and do all the required magic over there. So we select truck, we select reveal in Finder, and we open up Blender, delete cube, and import object. Unfortunately, Blender doesn't integrate with OS X Finder, so I'll have to figure out where was the object file stored at. Hacking, what else? That was on Friday, I think. EasySuspension, assets, truck, this one. Here we go. So we got truck imported into Blender. And as we can see, we have two meshes, so it comes in two objects. First there is the main body mesh, and then there is this thing, but still the wheels are connected to the main mesh, so we'll have to separate them. So there are different approaches, and I will just be showing one simple approach, I guess. So here we are in the object mode. We'll just switch to edit mode and also enable selection of faces so that we are able to select individual triangles. Let's select one of the triangles, and we want to be selecting all of the connected triangles. So for this, we go to select and go here, select linked triangles. Here we go. So this way we just get all of the triangles of the wheel selected, and now we can simply separate them from the main mesh. We go to Mesh, Vertices, and Separate by selection. And we already got the wheel separated from the mesh. So now let's simply repeat the action for all of the remaining 5 wheels. First triangle, then select linked, which is Control L, and then separate vertices, separate, which is P. Select triangle, Control L, and now P and selection. Good. Select triangle, Control L, P and selection. Now the same thing again, and once more. Right. Now if we go back to object mode, we need to examine our wheels again. So here, for instance, I see that the vertices of the wheels, they are still configured relative to the truck center, which is here. And that is not super convenient, because I can't really set transform to those wheels directly, because they will be rotated around this pivot point. So what I want instead is to have this pivot point right in the center of each individual wheel. For this, we go to Object, Transform, Origin to Center of Mass. And now we get the pivot point right at the center of mass. And now we have to repeat this procedure for all wheels. We go to Transform, come on, center of mass. Transform, center of mass. And now the right wheels. Transform to center of mass. Now transform to center of mass. And once more, center of mass. Good. I think that's almost all we need. One additional step that I'll do is I will rename the wheels to the name site. I basically prefer. So this one is axle 0, and this is left wheel. Now next one. So this one is axle 1, left. This one is axle 2, left. This one is, come on Blender. This one is axle 0, right. This one is axle 1, right. This one is axle 2, right. Good, so now that I have correct namings, I just go and save the file. Okay, so that's Friday EasySuspension truck. Let's name it Friday truck, like this, and save, and go back to Unity. I think I can delete the original files. Here we got Friday truck. Let's see if it's everything all right with the truck. Yeah, looks nice. Yep. So we got all of the wheels separate. So now I can turn them individually. So this one, for instance. Great. So now let's start adding dynamics to the truck. So we have this small car with box and 6 wheels over here, and what we need to do is to basically replace the cube with the graphics from here, and we also need to position WheelColliders right at the locations that are given by the graphics wheels, and then we'll be applying a script that'll basically compute the positions of the physical wheels and apply poses of the physical wheels to the graphical ones. Right, so here we got this car, and as the first step we just move Friday truck right on the car route, like this. Now I'll simply reset transform on the truck so that it gets perfectly centered with the rigid body over here. Now I'll take the collider because this truck doesn't have a collider yet, and we need the collider to correctly compute inertia tensor as well as correctly interact with other objects. So I'm taking the cube and simply adjusting it to look pretty much like the truck. Is it wide enough? Well, yes. It's okay. Is it long enough? Maybe not so. A little bit of tweaking. Here we go. And let's scale it vertically as well. Move a little bit higher. Yeah, I think it's enough. Yeah, it looks reasonably well. Good. Now I'm going to remove the mesh renderer because I do no longer need the mesh renderer here. Remove component. So here we can still see box colliders gizmo, the green lines over there. But the car is now displayed as a car. Here we go. What next? So next we need to position physical wheels correctly. This could be done in 2 ways. So one way would be to add a script that would simply add WheelCollider components just right on the graphics wheels. Another approach could be to move the physical wheels game objects manually. This is what I'm going to do, and I'll be showing a simple trick. So this trick is based on the fact that when you take an object and then reparent it to another game object, the wheel position is being conserved. So what I'll do is that I'll take a physical wheel and parent it under the corresponding graphics wheel, reset transform to get the wheel right in the center of the visual wheel, and move it back, because I don't want the physical wheels to be parented under the graphics wheels. I can still do the opposite, but I don't want to destroy the prefab connection. Here we go. So here I take the first wheel, just parent it to A0L, and now repeat once again, again, and again. So as you can see, the physical wheels are still at their positions. But now I'm selecting physical wheels like this and resetting their transforms. Here we go. Reset. And voila, I magically get physical wheels right in the center of their corresponding graphics wheels. Let's switch to wireframe mode. Here we go. Now I move them back to car root. Here we go. And one additional step, as I can see, the radius of the wheels is not still quite correct. The graphical wheels are just slightly bigger. So I still have all the wheels selected, and I will just adjust the radius value like this. Okay. Great. So now if I press play, like this, I can see, well, what can I see exactly? I can see it works. But still, the graphics wheels are not rotating, and they are also not inheriting the steer angle. That's because we have to write this code manually. This is done because that way you can have a custom code that works with tire compression, and also you could have a different amount of graphics wheels than you have physical wheels. Like sometimes for certain cars or motorcycles you want to have more physical wheels than graphics wheels to get more extra stability. Now let's enable graphics wheels. To do this, we have to add a controller script that comes with the EasySuspension demo. Here we go. First, let's see what's inside. So typically I would use MonoDevelop to edit the script, but currently it turns out that if I use MonoDevelop, I can't capture video and sound with QuickTime Player, and it simply crashes. So I will have to use any text editor, I guess. So let's open Sublime. So I'm just dragging all of the assets here to be able to use Sublime's search window, like rear wheel drive. So this is the controller code. let's go through what it does. So it has start function as well as update. So on start, it simply finds all WheelCollider components that we have underneath car root object. Then we iterate through all of the WheelCollider components and see if we have wheel shape assigned. And if we have, then we instantiate graphics wheels and parent them right under physical wheel. So here in update function, we get angle and torque values right from input, then iterate through all of the wheel colliders again, and set steering angle, set motor torque, and here we see if we have graphics wheel shape assigned, and if we have, then we simply update its position using get world pose and direct assignment over here. So since we already have graphics wheels in the model, we don't need the code that will create them. So I guess one of the easiest approaches would be to simply edit the script to fit our current purpose. So now I will just duplicate the script, call it differently, that'll be XP, which is for experimental, and I guess I need to rename it here. Let's see if it compiles. Yes, it does. Let's go to car root again and replace the rear wheel drive, which is the original controller, with our new one, rear wheel drive XP. Here we go. And now let's adjust the code. We no longer need wheel shape. What we need is we need a way to find a graphics wheel that corresponds to our physical wheel to set the transform over here. And as we can see, we have names already matching. So this is physical wheel A1 A0L, and the graphics object that corresponds to this physical wheel is A0L over here under the Friday truck object. So we can simply write a code that would find the corresponding graphics wheel using simple name matching. Of course, it's not performance friendly, but we can move this to start and do this only once, or we can simply come up with a better approach later. But for this simple example, I think it works. We'll just do the matching every frame. So let's write some code. So first, I need the transform, which is Freddy truck. I'll call it visual car. So here I still find all the wheel colliders. That's pretty fine. But I think I no longer need this bunch of code to parent graphics wheels because I have them already created, and I don't want to destroy the prefab hierarchy. I'm removing the code. Next, we still need to get input values. We still need to iterate through all of the physical wheels. We still need to set steer angle and motor torque. Here we don't have to check for wheel shape because we know that by now we want to do this. Unlike in the EasySuspension demo's original script where it was optional. We got the world pose of the current physical wheel, and here we just need to figure out the transform of the graphics wheel. So to do this, we take visual car and find child, which is called the same way we are called. So our name is wheel name. So we find this code takes the current physical wheel name and finds the game object with the same name right under the visual car, which would be a Freddy truck. So we, as I said, we will this code will get A0L and find the same game object on the Freddy truck and assign the position and rotation as well. So let's see how it works. We go to car root, and wait until it compiles. So we have this parameter, visual car, that's Freddy truck. And let's see how it works. Boom. Right, so we can see that the front axle can turn freely. Right, all the wheels are working. Yeah, they are working. Cool, cool. So let's select car root, press F 2 times so that we can focus our camera and see how it works. It's quite easy to come up with a custom camera code, but I still prefer looking at the cars in the scene view because it's a bit more flexible. You can position your cameras the way you like. The only restriction is that you have to remember to press focus on car root 2 times and click on the game view then. So now that we have an initial iteration running, it's time to tweak values and have fun. So first, I think this truck was all-wheel drive and not rear-wheel drive. And the controller, which we inherited from the EasySuspension, works in a way that it looks at the Z coordinate of every physical wheel, and if it sees that the current wheel is below the center of gravity along the Z-axis, then it's rear wheel and it drives. And if it's in front of the center of mass along the Z direction, then it's not driving wheel, it's just steering wheel. So let's change that. So to change that, we simply go to script and see this update function, which iterates through all of the wheels. Here we see that local position Z is being compared to 0, and if it's greater, then we set steer angle, and if it's less, then we set motor torque. Let's simply remove this, so that now we'll set motor torque always. That will make this car an all-wheel drive car. Let's see if it works. So now it's compiling, and now we press play. Correct. So now it's all-wheel drive car. So what next? So next, you might want to increase the max torque of the engine. So the greater the value you set, the faster your car accelerates. But also pay attention to slips values. If your engine is too powerful, then it may end up in a situation where all of the wheels just spin badly and they have little to no grip. And even though you have a very powerful engine, the car won't be able to accelerate too fast. If you have this kind of situation, you could go two ways. First, you could lower the max torque value Or you could go to WheelColliders and adjust forward friction to make sure that you still have a lot of grip even at the high slip values. Another group of interesting parameters is over here. Those are natural frequency and damping ratio. So currently we have 10.8 respectively, and those are parameters for a typical family car, but this is not a typical family car, is it? So let's just change those and see what happens. So if you change natural frequency, you see that the truck just lifts up. That's because EasySuspension script computes suspension distance based on the natural frequency, and the lower value you set here, the softer suspension you get, but it's also resulting in higher suspension distance values. Then damping ratio affects how bouncy the suspension is. So if you set it closer to 1, it'll set the parameter which looks like a really stiff suspension which has no oscillations. And if we set it to lower values, like this, it'll be a pretty bouncy car. You can see that it still takes time for oscillations to calm down. Here we go. So there is still much more than can be done with this truck, but I think I still want to keep this video introductory and simple to understand, and I think that's a good stopping point for me today. So thank you for being with me. Thanks for watching, and press like if you like the video, and leave a few comments below. There will be also the link to the EasySuspension project just in the description. And shoot an email if you have questions, and see you next time.